Installation and Operation Manual for Horizontal Split-Case Double Suction Centrifugal Pumps. This manual contains instructions for the installation, operation, and maintenance of the horizontal split-case pumps. Welcome to the General Video Reference and Guide. Please read the product manual before installing the machine to get knowledge of the pump works and how to install it. This is a brief overview and demonstration of the entire process covering the key points. Radially split casing design allows removal of the impeller and bearing housing assembly without disturbing suction and discharge pipes. Storage and protection. All pumps are tested and ready for operation when delivered. If the pump is stored for long periods of time, it should be kept in a clean and dry area, and the following precautions should be taken to ensure that the pumps remain in good condition. Precautions. Be sure that the bearings are fully lubricated. Shaft should be rotated 10 to 15 revolutions by hand periodically to spread the lubricant over all the bearings. Suitable intervals are 1 to 3 months. Installation. The pump should be located as close as possible to the liquid supply, so the suction line should be short and direct. Location should require a minimum of elbows and fittings to minimize friction losses. Before installing the pump, ensure that the foundation on which the pump will be installed is prepared well. It has to be sufficient enough to take the weight of the pump and absorb any possible vibrations from it. The foundation has to be absolutely straight without any inclination. The foundation bolt of proper size should be embedded in the concrete and base plate. Piping associated with the pump must be supported independently of the pump and should never put any strain on the pump casing. When the pipes are not supported, their weight is covered by the pump casing, and this situation may cause cracks on the pump casing. It's important that the connections are aligned axially, angularly, and in length carefully. Suction line. Negative suction. The piping and the connection fittings should be properly aligned and supported separately. The elbow should be of long radius type. All suction piping must be airtight. The suction pipe should be sized to ensure the liquid velocity of not more than 2 meters per second. The suction pipe's size should be at least 1 commercial size larger than the pump inlet. All suction pipes should have a continuous rise to the pump suction inlet. 6 mm to 100 meter slope is recommended. No isolation valve is recommended. There should be a pressure tapping provided for installing a vacuum gauge in the suction line. The reducer joining the straight length of the pipe in the pump line should be an eccentric reducer with the inclined side of the reducer as the bottom side. The straight length of the pipe after the eccentric reducer should be 2 times the pipe diameter. The suction strainer must be at least 4 times the suction pipe area, and the mesh size should screen out solid particles that would clog the impeller. The minimum depth of submergence of the strainer should be at least 4 times the pipe diameter measured from the upper row of holes strainer. The distance between the bottom of the strainer and the floor of the tank should be 2 times the pipe diameter. A short elbow should never be bolted directly to the pump's suction nozzle. The disturbance in the flow caused by the sharp bend causes noisy operation, loss in efficiency and capacity, and heavy end thrust. If separate suction lines cannot be used for each pump, then water has to be supplied with wide branches. A straight branch header should never be used. Suction line. Positive suction. In case the water is being supplied to the suction through gravity, a slightly different setup is needed. The elbow should be standard type or long radius type. Isolation valves should be provided in suction line. The pipe from the tank to the pump should have a descending inclination. The straight length of pipe between the pump inlet and tank should be at least 3 to 6 times the pipe diameter. The suction pipe should be sized to ensure the max liquid velocity of 3 meters per second. There should be a pressure tapping provided for installing a vacuum gauge in the suction line. The reducer joining the straight length of the pipe in the pump line should be an eccentric reducer with the incline, the side of the reducer, as the top side. Discharge line. There should be a pressure tapping as close to the pump outlet and before the isolation valve as possible to measure the pump shutoff head. Concentric reducer is installed in the discharge side to minimize the friction losses. To prevent reverse flow and protect the pump from hydraulic shocks, check valve has to be used in discharge line. The isolation valve is provided downstream of the check valve so that these can be taken up for maintenance, priming, and starting whenever required. Discharge pipe size should be at least one commercial size larger than the opening of the pump outlet. The number of fittings and size changes should be minimized to prevent fluid friction losses. Expansion joint may be used only after a careful piping analysis, especially when the discharge pressure are on the higher side. Installation of pump and prime mover. The pump unit needs to be fitted with using nuts and bolts before fitting in any pipes. The pump and the motor are aligned to the final tolerance using a reverse dial gauge or laser alignment tool. After the alignment is completed, the piping connected with the pump should be built. Once this is completed, the alignment of coupling should be rechecked. Then the alignment of all piping and fittings should be rechecked and suitable corrections should be made. Misalignment causes noisy pump operation, vibration, premature bearing failure, and excessive coupling wear. When the pump and motor have been coupled, movement of the shafts should be controlled manually by hand to see if it is rotating smoothly. Operation. Before mounting the coupling guard, check the drive rotation to see that it matches with the pump rotation. Starting, check the bearing lubricant. Open the valve in the suction line if fitted. Close the discharge valve. Prime the pump. Start driver. Open discharge valve slowly when the pump is up to speed. Shut down. Pump can be stopped with the discharge valve open without causing damage. However, in order to prevent water hammer effects, the discharge valve should be closed fast. Close the discharge valve. Stop driver. Close the valve and suction line if fitted. If any danger exists, drain the pump completely.